Hello everyone, you are welcome to today's lesson. And in today's lesson, we have a simple task, and the task is to look at the solution to the class test that was given on the topic algebraic expressions. So after we were done with this particular topic, algebraic expressions. Okay, so without much ado, let me go and walk you through the solution. And the solution that we have here. Okay, please take note. You can see, okay, marks allotted to steps. So indirectly, the solution that we have here is to equally help you, okay, mark. So what we have here indirectly is a marking scheme. And as I walk you through the solution, I will address some of your concerns, if not all, especially the major ones. I will address all of them that came to bear, okay, from your various submissions. So once again, stay with me whilst I humbly take you through, okay, the solution. All right, so remember, you've been told and advised that anytime you read questions, make it a point to underline the salient part, if any. So with this one, expand and simplify. Usually when you are asked to expand, you have to simplify. Even if you don't see a simplify with it, you can't just expand. After expansion, you must always simplify your results. Okay, so here there is nothing salient for us to what underline. So now the first thing that you write is solution. Okay, solution. After that, questions are numbered because we want you to equally number your solution. So failure to do so will be costly. So if you don't number, it means you've lost all the marks. You know the rule. Okay, so in this case, we are looking at solution to question 1. Okay, and question 1A. You come and extract the expression that you are asked to expand and simplify. So you write it. Extracting that alone will give you 1 mark. Okay, then there's an expression you start with equal to. Immediately you start with implication. Okay, please take note. You've lost your way because at this point I've told you severally, you need to know when to use the implication sign and the equal to sign. They cannot be used interchangeably. Okay, so this will be equal to, so we come and remove, okay, the brackets here. Okay, you have 2 sets of brackets. At the normal circumstance, when you are distributing, indirectly you are removing the first set of brackets, but because the coefficient of your first term here, okay, is 1, when you are distributing, you can choose not to put, okay, the whole of that in brackets. I'm talking about your 4 terms that you have here in brackets, just for the simple reason that I just, okay, mentioned. The coefficient is 1. That is the coefficient of this term. The factor here is 1, and it's positive 1. So in that case, if you distribute all the brackets here can go. Now minus, then you come here. Here, because what you have before this term is negative, forgive me, is negative. Okay, what do we do when you distribute? Take note, the brackets will not vanish. So you keep the negative or the subtraction key that the subtraction operation that you have here, and what you now come and distribute. So as you distribute, you have it in mind that it's only 1 set of bracket that is going. So when you distribute, the other or your terms must be in brackets. So after distribution, okay, what do? You come and simplify your terms. So I simplify this, which gave us what we have here, the first 3 terms here. Then minus came to simplify what we have in bracket 2. And someone can choose to push the negative through before, okay, simplifying. Or somebody can do the 2 at the same time. Simplify and put the negative through. So it means someone can move from here to here straight away. If you do so, you won't lose this mark. Okay, you will get 2 marks for your method here. Take note. So as you come and combine the like terms here, you end up getting this. Okay, and as you combine the like terms here, you end up getting this. Okay, after that you remove, okay, you push in the negative. So that will give you what you have here. And after that, you combine like terms, and that will give you this. Okay, so the whole of this, you can see the marks there. Now we come to the solution to that of the B. B2, you extract what you are given. So this should be here. And I've told you can choose not to write given, but this must be extracted. Then this obviously is an expression, and we are asked to, okay, expand and simplify. So your first step should be equal to, or you introduce your steps with what? Equal to. So you can see that just as I did here, any step on the way was introduced what with what the equal to sign. So it's when you are going to draw your conclusion that you do this. And someone equally can choose not to write the given here, or can put therefore here. So in that case, the person will not write this. The person will end at this and still get the full score because the conclusion is embedded. And this one same. All right, so at this point, I've been given two binomials. And remember, the advice was anytime you are given two binomials multiply, check whether you are dealing with a special binomial. A special binomial will be the situation where you have same first terms, same second terms, either same signs, okay, between okay, each factors, okay, or opposite sign. So if you look at this, we have same first term, same second terms, but difference in sign. Okay, and we know that if you have this situation, anytime you expand, you get difference of two squares. So there's the factorization, okay, of difference of two squares. So if I expand, I will get difference of two squares. So my expansion will give me the first term here squared minus your second term, okay, squared. Okay, so on that note, you know, if you fail to put this in brackets, your 2a in brackets before the square, please take note, it will be m0 then a0. That must be, even if you get the answer right, okay, you've lost your way. Because without the brackets, you shouldn't get 4a squared. You are supposed to get 2a squared. Take note. Without the brackets here too, you shouldn't get 1 over 9b squared. You are supposed to get 1 over 3b squared. Take note. So the brackets must really be indicated. So difference of two squares expansion, which will give us this. Then after that, we know we are supposed to remove the bracket, expand, remove the bracket. So we can still see bracket there. But if you remove the bracket here, you will get that you end up getting 4a squared. Remove the bracket here, you get 1 over 9b squared. And at this point, you know you are landing at your answer. And just like I told you and advised in class, you can draw your conclusion here, or you can better still write therefore here equal to. In that case, you don't write this again. So you land here, you still get your full score here. I think 4 marks for this, and here I can see 5 marks. So quickly, let's go and look at that of the C. Okay, the C, we are giving AB plus what CD, the whole of that squared. Okay, so again, you can see that here we have a binomial squared. And remember, we know that anytime you are expanding a binomial squared, okay, A plus B all squared will give us A squared plus what 2ab plus b squared. So if you expand, you get your first term squared plus the twice the product of your first term and what your second term of the binomial, then plus what your second term all squared. So it is the same identity that we are going to make use of here. So if you extract this time right, it is b half. Then now what do you do? That will be equal to your first term squared. If you expand any binomial squared, your first term squared, because this is plus, it will be plus twice the product of your first term and your second term. So that's what we have here. Then plus your second term squared. So every binomial squared, if you expand, you get a trinomial. That's what we have here. So at this point, you can see again, if you don't put the AB in brackets, your CD in brackets, even one of them not in bracket, please take note. Okay, it will be M0, A0. You only get the marks for your extraction, provided you extracted, okay, just as you have. Then again, if you use implication, M0, A0. So because you are dealing with an expression, your steps must be introduced with the equal to. So my next step, I know that I will land at my answer. So if I'm going to remove the final set of bracket that I have there, I will land at my answer. So AB squared or AB all squared will give me A squared, B squared. That's what we have here. And twice the product of this will be 2 times A times B times C times D. So it will be 2 A, B, C, D. And that is what we have here. Then CD, the whole of that square will also give you C squared, D squared. And like I said, someone can write therefore here instead of the giving, then okay, in that case, the person will not write the side. Will just come and write equal to and write this. So the person will land at the answer, okay, straight away. All right, okay. Now let's look at that of the D. Okay, the last question and the question 1. Okay, of question 1. So what do we do? Again, we have a binomial squared. Okay, only that this time around, in between your binomial, okay, the sign there is negative. So it's the same thing. Okay, A minus B all squared, we know the identity. That will give us A squared minus 2AB, then plus what? B squared. So here your A is this, your B is this. Okay, A is 1 over 2x, B is what, 2y. Okay, and here we are supposed to put it in brackets when we are applying the identity, each of them. So this will give us what? Our first term squared, which is half x, okay, squared. Failure to put it in bracket will be costly again. Then minus twice, because this is minus, your middle term will also be minus. So it will be minus twice the product of your first term here and your second term. So twice the product of your first term, which is this, then your second term of the binomial, then plus your, okay, second term squared. Okay, and please take note here, this must be, you take 2y as your b and 1 over x as what, your a, not b to be minus 2y. Please take note. If you take b to be minus 2y, then this sign must be kept as what, as positive, because it means you are taking what you have here as half x plus minus 2y. So if you come and do that and take your b to be minus 2y, then the sign here should be plus, so that this will be minus 2y, and later come and give your middle term negative. But remember, that wasn't what I taught you. Okay, so go by that first term, second term of your binomial. So at this point, if you come and remove the bracket here, this will give us half squared, which is 1 over 4, then s squared. Okay, then this will, the 2 will cancel, so I'll end up getting 2xy. And this one will give me 2 squared, which is what, 4, then y squared. So at this point, I will land at my answer. So I have my answer mark over there. So this one will be 2.5. Take note, this is also 2.5. So in all, question 1 is 14 marks. Okay, so take note. So we are going to move on to question, okay, 2. Question 2, we are supposed to factorize the following. Okay, so indeed we are supposed to factorize. So if you like, you can underline factorize. Or I've told you, when it comes with completely, that you underline completely. But even I've told you, anytime you are asked to factorize, whether completely is stated there or not, your factorization must be completely done. Okay, so take note. So it means your final result shouldn't be factorable. You shouldn't be able to factorize what further. So please take note. So in this case, 2a, what are we giving? And you can see that the questions are basically questions that you've seen before. Okay, all right, especially those who sat through, okay, all the lessons in this particular topic, okay, algebraic what expression. So quickly, let's go and look at, so solution is what you write first, the question number. Okay, so the major question number is 2, the minor question number is a, given, or someone can write therefore. Okay, so what do we have here? Given this, you extract. As for the extraction for this one, we have. Then that will be equal to, obviously you can see a quantity squared minus a quantity squared. So anytime you are asked to factorize and you see your first term, 2 terms, okay, and that was giving your first factor or your first term is a quantity squared minus your second term, you can also see a quantity squared. Okay, or first term a quantity squared, second term a quantity squared, and you see the subtraction sign, okay, between them, then it means we are dealing with difference of 2 squares. And difference of 2 squares factorization, we know, okay, that if you have a, let me see if I can write that quickly. Okay, so here, if I have a, okay, squared minus b squared, we all know that this will give us a plus b as one factor, then a minus b as the other factor. So you take note. So in this case, we should know, let me go for the laser so that you can clearly see. You should know that what your a is s plus 1 here if you compare, and your b is not that explicit. Okay, you can see 4x squared, but you don't see the direct quantity that you are squaring. So it's this that must be transformed. This one, you can see the direct quantity that you are squaring, which is s plus y. So in this case, if you transform this to be obviously quantity squared, then we are going to get 2x, okay, squared, so that we can compare and get our a to be s plus y and b to be what, 2x. So if you go and substitute, we are going to get, okay, a, which is this, plus what, your b. And you know that because a contains a bracket, when you are going to apply, your first set must have the square bracket. Okay, and your second should also have the square bracket because there will be a bracket inside a bracket. Okay, then your second factor here will give you, okay, this minus that. Okay, so at this point, you come and remove the inner bracket. If you move the inner bracket, the outer bracket, which is the square bracket, will take the form and shape of what your inner bracket that you have here. So if you remove the inner bracket, it will be 1 times, which will give you x plus y plus 2y. So the outer bracket becomes the ordinary bracket. Then the inner bracket here will also be removed. So if you remove here, this will be your result. Okay, so at this point, what do? We know we can simplify this because we have like terms. We simplify that. If you end here, you won't get the final answer score. Please take note. So this simplified will give us 3x plus y. However, this simplified will give us what? It will be minus x plus y. But remember the advice, in any expression, it is better to write the positive term first. So in that case, you write y minus x instead of minus x plus y. If you wrote minus x plus y, then you are going to get what? I think I told you in the assignment, okay, this question was given in one of your assignments, so I'm not going to be lenient. If you didn't start with a positive, it will be a0. Take note. So if you wrote the second factor as minus s plus y, it will be a0 because I know I have advised you not to do that. Okay, all right. So now we move on to that of the B. The B2, okay, this is the expression given. Okay, so you extract. Okay, and that will give you or attract 1 mark. Then after that, what do we do? Remember, I've told you in any factorization, the first question or set of questions that you ask yourself will be: do I have a common numerical factor? Okay, that I can bring out? Do I have a common variable factor? Okay, that I can bring out? If so, you do. But if you don't, then you have to go and look at your other factorization technique. So here, if you look at this critically, in terms of the numbers, okay, the coefficient, the numerical coefficient, and we can obviously see that 2 is a factor to all the terms there. So we can bring the common factor, numerical factor 2 out. If you study again, you realize that the variable x is common to all of them, so you can bring s out. Then you also bring what? Y out. So if you do that, then because you have 4 terms here, we are going to have 4 terms in our what? Our brackets here. And how do you get each term? Okay, it will be each of the terms in the original divided by the factor that you've taken out. So it will be this one divided by 2xy, which will give us 5x. This one divided by 2xy, which will give us, okay, xy. Remember the negative, the subtraction will be there. Then plus this also divided by 2xy, and that will give us 5. This, so your minus will come 2xy, okay, squared divided by what? 2xy, and that will give you y. So that will give you your first factor and your second factor, the one that you have in bracket. However, if you study the second factor carefully, you can see that you can still, okay, factorize. Okay, in that case, you have 4 terms. Okay, so 4 terms, what factorization technique should come to mind? Factorization by grouping. So let me see whether if I group the first 2 and the last 2 and I factorize, I will get each 2 sum to contain a common factor. So if I factorize this, x will come out 5 minus 1, y. 1 will come out. Okay, so yes. So factorization by grouping, okay, will be useful here. So if you end here, your factorization is not complete. Okay, so in this case, what do we do? Forgive me, you come and what? Write your 2xy there, and you know this an expression. Each step must be introduced with the equal to sign. So what do we do at this point? We write our 2xy, then come and factorize this. Once you are going to factorize this, you know that there will be brackets that will be introduced, but already you have brackets here. So you introduce your original bracket here using the square bracket. Then first 2 factorize will give us what? X. X will come out, then you get 5 minus y. Last 2 factorize will give us 1 out. You can choose not to write the 1. Okay, 5 minus y. Okay, then I've told you, close your square bracket. At this point, what do? We are done with the factorization of this, because if your next step, you are going to give us the factorization of this one completely. So that will be s plus 1 into 5 what? Minus what? Y. So in that case, you get 2xy, and the factorization of what you have here in the square bracket will give us the result here. So at this point, okay, that becomes your final answer because none of the factors here is still factorable. Okay, so I guess my point is well, okay, made. If you wrote therefore here, then there shouldn't be this statement here. Okay, you should have equal to, then you land here. You still get your full score. Take note. All right, and again, if you didn't use the square bracket and you use the bigger ordinary bracket, it is allowed. Only that I've told you, learn to do the right. And once you have the ordinary bracket, okay, outside bracket should be the square bracket. Okay. All right, so now let's go and look at what that of the C. See, this is what we are given. Okay, all right. So at this point, obviously, we can see a quadratic expression there. So the same uh, advice anytime you are asked to factorize, ask yourself whether there is a common number that can be brought out or a common, what do you call it, variable or variables that can be brought out. Okay, so in this case, this is a quadratic expression. You know, anytime you want to factorize any quadratic expression, first of all, rearrange so that the powers of x will be in descending order. Okay, so if you rearrange, we are going to get negative 20x squared, okay, then minus 12x, then plus. So it's just rearrange. Your ability to do that will give you attract this mark. If you extract B half, you know the mass there, so I won't talk much about it. So here, having rearranged, you will see that your numerical factor, remember if your leading term is negative, then it means you are going to factor out a negative, okay, numerical what factor. Okay, so now I can obviously see that, okay, 4 is common. So I will factor out 4, but because my first term is negative, okay, it will be negative what 4. Then how do I get my terms in brackets? Okay, by dividing each of the terms here by the negative 4, and that will give you the 3 terms that you have here. And now you can obviously see that this quadratic expression will not be factorable, because if you multiply 5 times negative 4, that will give you negative 20. And there is no way you get a factor pair of, okay, 20, that when you multiply, you get negative 20. And when you add, you get positive 3. Or you can still do your b squared minus 4ac test. Okay, if b squared minus 4ac gives you a perfect square, then it means you can get the factor pair of 20. That when you multiply, you get minus 20, and you add, you get what, 3. But that b squared minus 4ac will not give you a perfect square. So it means even if I give you your entire life, you wouldn't be able to factorize at this level. So now what do? We come and draw our conclusion methods. Someone could have drawn the conclusion here, no issues. Okay, so in that case, you still get your full score. Take note of that, because what I have here is repetition. And remember, I've told you to avoid what repetition, because you can't factorize. Okay, all right. So at this point, what do we do? Okay, the D, we move on to the D. Okay, so D, what do we do have? You've been given this. Okay, you are asked to what do you call it? Factorize. So please, this is the advice as you were told in class. Anytime you are giving terms that at least one of them contains a fraction and you are asked to factorize, okay, take a single fraction form, okay, of the expression before you start your process of what, factorization. So that's exactly what I did. I came to take the single fraction form of this, meaning equal to I take the LCM. So express this as a single fraction before you start factorizing. Okay, so the LCM will be 36. So you ask yourself, 4 will go into 36 how many times? It will be 9. 9 times what? 1a squared will give you 9a squared. Then minus 9 will go into 36 how many times? 4. So 4 times, okay, 1b squared will give you, okay, 4b squared. Or 4 times b squared will give you 4b squared. So that will be the numerator. So equal to. Some of you didn't write equal to. Remember, if you are taking it as a single fraction, you are working on this. So it's still a step, and you have to use the equal to do that. And some of you wrote LCM. If you want to write the LCM, that's the safe way. Don't write the LCM as a rough word. Don't let it interfere, okay, with your main word. Your LCM should be known, just known mentally or what have you. You don't need to write it. Who will know that this is the LCM? Because that will be the denominator that you write there. So please take note. All right, so at this point, what do we do? The denominator is not factorable, just a term. Now let's go to the numerator. The numerator, we can see a quantity squared minus a quantity squared. So we can obviously see that it will be useful for us to make use of what the factorization technique, difference of two squares. So let's see, this quantity, is this obviously okay, a quantity squared? It is not obviously a quantity squared now. But if you look at it carefully, you see that 9 is the same as 3 squared. So what I have here, I can write it as 3a, the whole of that in bracket square. If the bracket doesn't come, you are wrong. Take note. This one will also give you your numerical factor here, the 4, is also a perfect square. So it will be 2 squared. So it means this is going to give us what? 2b, the whole of bracket, or the whole of that in bracket square. So it's the numerator that we know we are using. Now, obviously, 2 binomials was squared, the difference. So if you factorize, it will be your first, okay, plus the second. So in one bracket, your first plus the second. Okay, then in the other bracket, your first minus what? The second. So that will land us at our answer. So that gives us this as what? The answer. So please take note. That will be it for the solution to question 2. Now, quickly, let's go and look at what solution to question 3. Okay, so question 3, the first one, what do we have here? Okay, we are asked to simplify, okay, the following as far as possible. So in this case, you know, simplification, okay, whether you see as far as possible or not, at normal circumstance, this is what we are supposed to underline. But anytime you are asked to simplify, your simplification must be done as far as possible. So take note. All right, so now you, after reading the question and underlining the salient part, the next thing that you write is solution, then the question number. Don't forget. Okay, so now you come to the minor question number A. Then what do? You be given, you extract, and that is what the B1. Then after that, what do? You check if you can, once you have a rational function and you are asked to simplify, check whether the numerator expression or denominator expression, okay, any of them can be factorized. Because it's only as a result of that that we can, okay, check or see, make that determination that we can reduce or not in terms of simplifying. So at this point, this is it. Okay, the numerator here, you can't factorize, but the denominator you can factorize, a quadratic expression. Okay, so a quadratic expression, you ask yourself, okay, because the leading coefficient is 1, it means my concentration should be on what? On the constant here, 4. So I look out for the factors of what? 4, factor pair of 4, that when I multiply, I will get positive 4, and when I add, I will get negative 2. So and obviously you know that we are going to get what? Negative 2 and negative 2. So in this case, you know that what you have here is a perfect square trinomial per experience. Or better still, if you want to, I've told you if the leading coefficient is 1, you can factorize straight away. So it means you are going to get one bracket, another bracket, okay, your first bracket x, because your quadratic is in x, your second bracket x. Then you look for the factor pair. Okay, and the factor pair we said is negative 2, negative 2. So we are going to get this, but we know that this is better written as what? Okay, x minus 2 all squared. Okay, however, if you want to leave it like this, no issues. But you should know, in one of our lessons, I told you that anytime you have a plus b, okay, over a plus b, that cancels and gives you 1. If you have a minus b over a minus b, okay, that reduces to also 1. However, if you have a, okay, plus b over a, b minus a, okay, where you have the swap, in this case, this will give you negative 1. Again, if you have a minus b over b plus a, okay, this will also cancel and give you negative 1. So you should know this, where one is a swap of the other and the sign has been changed. Okay, so it means this 2 minus x can cancel one of the x minus 2, but it will give you negative 1 because swapped. It's my point well made. This, please take notes. This is not what I meant. It will be a minus b over this. Then this will be plus, okay, no, a minus b over b minus a, or I wanted to write b minus a, okay, forgive me, over a minus b. Okay, when you see that they are swapped, they are not the same. You can see that this is a minus b, but the other one, a minus b over b minus a. So one of them is the swap, okay, of the term. So once you see that, then that will cancel and give you negative 1. But if they are the same, then it will give you positive 1. So please, okay, bear with me. So this one is not what I was told. So this one should be, I think I wanted to make it this one A. Like I said, this should be B and this should be A. I wanted this to be the numerator and this the denominator for you to know that it's the same, basically. All right, so at this point, I guess I have made my point clear there. I've rectified, okay, what I initially wrote. which was wrong anyway. All right, so in this case, now that you know the writing, we know that 2, if I have 2 minus x over, okay, x minus 2 into what? X minus 2, that's how it's supposed to be. 2 minus x will cancel the x minus 2 and give me negative 1. Okay, so I'm going to get negative 1 over x minus 2. So that's exactly what we have here as your final answer. Okay, so please take note. Then we come to that of the what? Of the b. Okay, b, we are given this divided by this, so you extract. Okay, so what do we do? I've told you anytime you have an algebraic what? Fraction, okay, a rational expression, and you are asked to, okay, simplify numerator, denominator, any of the expression that is factorable, you factorize. Okay, so that's what I'm going to do. However, I am going to combine the factorization and I will change, because I know at a point I have to change this division symbol, okay, to the multiplication symbol. However, after doing that, you have to invert. Okay, so please take note. So in actual fact, I know that what I have here, please take note, I can use only one step to factorize. So that is it. This one, I can also use only one step to factorize. So that will give me the factorization. Then times, okay, the reciprocal of this, which is what you have here. However, you should know that, okay, numerator here is not factorable, but the denominator, which was initially our numerator here, but now has become the denominator because we have changed the division to multiplication. Okay, this one you cannot factorize by using just a step. So remember the advice, instead of doing your factorization here, take it out, go and factorize as your rough way. So I took this one out, did the factorization here. Okay, so it means you should know how to factorize this. Okay, factorization, first step, ask yourself, do I have a common number or variable that I can bring out? I have a common number, I bring it out, so I will be left with this. Then with this one, it's a quadratic in 2 variables, so you know. What do? You multiply the coefficient here, which is 1, the coefficient here, which is 3. So you multiply 1 and 3, which will give you, that's the coefficient of your squared terms, your first and the last. Okay, that's the numerical coefficient. So that will give us positive 3. So factor pair of positive 3, that when you add, you get what? Positive 4. You know that the factors should all be what? Positive. Okay, so that so it will be 3 and 1, so that when you add, you get a positive result. Okay, though you know that the product is supposed to give you positive, and therefore the factors possibly could be negative as well. Okay, all negative. But in this case, if they are all negative, I add, there's no way I'll get, okay, 2 negative numbers adding to give me a positive number. So the factors will all be negative or all be positive. So that's, we inform you that you have to settle on the positive 3 and the positive 1, or positive 1 and the positive 3, instead of negative 1, negative what? 3. So at this point, you use that factor pair to split, okay, your middle term here. So it will be 1, because the quadratic is in 2 variables. When you write a 1, which you don't need to write, is simply understood there. So you attach your variables that your expression depends on, which will be xy, then plus 3xy. That's the other factor that you attach that. Then here you come and do factorization by grouping. So take note, if you take the first 2 and you group and factorize, you end up getting, okay, first 2 and last 2, you end up getting this. So you should know what we have here. So this one, 2 will come out. If you factorize, you get s out, then you get s plus y. The other one, you get, okay, 3y out, then you get what? S plus what? Y. So that will give you this factor. And then you import your resultant factorization here. So now that's what I did here. Okay, so however, this one, you get 2 marks if you for the factorization of what we have here. 2 marks for that, don't forget. Okay, but if this happens to be a rough work, after that you strike it out and make sure it doesn't interfere with your main work. So always do it at the extreme, right. Okay, so at this point, having imported my factorization result, now I come and check whether I can do diagonal cancellation or vertical cancellation. So in this case, I know that these 2 will cancel these 2. Okay, my s plus 3y will cancel this s plus 3y. Then the s plus y will cancel this s plus y. So it means I will be left with, let me do the cancellation for you to see what you'll be left with. And it's not compulsory to show your cancellation if you are matured. Okay, so this will cancel that. This, forgive me, will also cancel that. Then forgive me, this will also cancel that. Okay, so it in effect, it means our numerator will be 1 times 1, which is 1, and the denominator will be the whole of this. Okay, and that's exactly what we have here. Take note. Okay, all right. So at this point, we can have our conclusion drawn. Or those of you who wrote therefore here, okay, you don't need to draw your conclusion again because your conclusion is embedded. Okay, now let's go to the last, okay, question. Okay, so the last question that we have here, the C, again, you extract. Okay, and remember, okay, factorization first, okay, or yes, usually we ask you to factorize first so that you can easily see the LCM. So this one is not factorable. You can't factorize anything here. It's this one that the denominator is factorable. So difference of two squares, which gives us what we have here. So at this point, you can clearly see that a minus 1 is a factor of this. A plus 1 is also a factor of this. So it means our LCM will be a plus 1, a minus 1, or a minus 1, a plus 1. So at this point, I can take my LCM, which will be equal to, come and draw my bar, then this becomes my LCM. Now I do have to do this. Okay, I ask myself, a minus 1 will go into your LCM. Okay, how many times? It will be a plus 1 times. Because if you divide the a minus 1 will cancel. So it will be a plus 1 going to multiply a plus 1. That will give you a plus 1 squared. Okay, then you come and bring your sign minus. Then a plus, sorry, oh, this one was a minus 1. Okay, going into which multiplied. I think I've explained that. Now let's come to a plus 1. A plus 1 will go into your denominator how many times? Okay, the a plus 1 will cancel. So you'll be left with a minus 1. So it will also be a minus 1 times a minus 1. So that will also give you the whole of a minus 1 squared. And quantity multiplying the same quantity will give you the quantity squared. Then you keep your sign here. Then your denominator here will go into your LCM how many times? It will be 1. Everything will cancel. Okay, then times 4. So that will give you the 4 that we have here. So at this point, you come and remove the brackets. So just as explained in the question 1, okay, when you are removing the bracket here, okay, you know you use the binomial squared. Okay, so a squared plus 2ab, so your b is 1. So twice the product of this and this. The product of this and this, a and 1 will give you 1. A will give you a. So times what? 2. So that's what you have there. Then plus, okay, 1 squared. So that will give us this. This one, okay, because the coefficient is positive 1, okay, the brackets will go entirely. Then minus here, the coefficient is not, okay, positive 1. It's minus. The sign there is minus. Okay, so at that point, you cannot remove the bracket straight away. So if you use the binomial, you get what? Also a squared minus 2a plus 1, because you know it will be a squared, your first term squared, okay, minus twice the product of your first term and second term. So first term is a, second term is 1. So twice the product of that is a times 1, which is a. Twice that will give you 2a, then plus 1. Okay, that deals with expansion of this. Okay, applying the square, pushing the square in the plus your 4, don't forget. Then at this point, you know denominator kept intact, never expand, okay, because you know it is only when it is in its factorized form that you can easily see whether you can cancel to reduce. So at this point, you come and remove the final bracket here. So if you push the negative through, this is what you are going to get. Take note. So after removing your final set of brackets, you combine like terms. So I know a squared and the minus a squared will cancel. The 2a, okay, plus 2a will give me 4a. Then I'm going to get my plus 1 minus 1 will cancel. So I'll be left with 4 for the constant. So over. And at this point, I can see that my numerator is factorable. And if I factorize, it will result in reduction. So I'm compelled to factorize. So in this case, what do? I bring 4 out and I'll be left with a plus 1. So this a plus 1 and this a plus 1 will cancel. So in effect, I will get, oops, okay, so it means my final answer is wrong. Let me quickly go and effect the change. Okay, the a plus 1 cancels, so it shouldn't be there. Okay, so let me clear the whole of that quickly. All right, so now I have effected, okay, the correction. So quickly, let me go back to what I was doing. So in this case, okay, so once I remove so I think let me do the right. Once I remove the first, it's because of the first factor that the bracket was introduced. So once I remove that one, then it means this will only be, okay, what we have here. The bracket wouldn't be necessary. That doesn't mean if you bring the bracket, you are wrong. only that it doesn't show maturity. You should know that the bracket wouldn't be necessary and therefore you can, okay, ignore. So at this point, this one will give us what, 20 marks. I think I did mention this one, the 2 will give you 17. So if you put everything together, the total score is supposed to be what, 50. And please take note, okay, if you left anywhere where you are dealing with questions and you are dealing with steps, if you left it one line in between your steps, each line is, okay, will attract a penalty of -1. Please take note, you don't leave spaces in between your steps. It's when you are moving from a sub question to another sub question, that's where you leave lines. Please take note. So take note of this, okay, or penalty. Okay, any line that you leave when you are not moving from a sub question to another sub question, each line will be -1. Take note of that. So on that note, okay, the total marks will be 50. And please, you know, okay, when you subject your work through this and you mark, indicate your score over the total score on top of your first page. Okay, on top of your first page, please take notes. Okay, so on that note, if you had 50, don't just write 50. Write 50 over 50. Let us see the denominator, which will give us the total marks. Okay, so on this note, I would want to say thank you very much for sticking and staying with me. Okay, God bless us all.